Greetings and welcome, friends. We're talking today about solving rational equations, and we've had multiple skills we've learned over time. We've learned how to multiply, how to divide, we've learned about complex fractions, we've learned about adding and subtracting them, but now we're going to use some of our familiarity with fractions and our skill sets to solve equations with rational expressions in them. But before we do that, I want to recall a concept. Really, we're just expounding even on this, that we called fractionicide, fractionocide. There we go. Right, was what we called it, in which if I had something like this, say I had 2/3 x plus 5/7 equals 1, and let's say 1/6, something like that. That's kind of a sad-looking 3 over here. There. Now he's happy. Is he happy now?
No, he's fat.
Okay. Yeah. Anyways, so if I was using the techniques of fractionicide, or clearing out fractions, as sometimes it's called, or killing fractions, how would I have done that? Do you guys remember the specific sequence, the code that we could use to genetically break down all fractions into whole numbers? Or integers?
Nope.
Well, it was related to their weakness, the LCD. If I find the LCD of all of the denominators, I can use that to kill them all. It's their common weakness. So let's see, 3 and 7 go into 21. 6, I think 42 is the LCD there, if I'm not mistaken. All right, I mean, I could have just multiplied all of them, but then that would have given me a common denominator, but really big. So the trick is, once I find the LCD, I just straight up multiply both sides by the LCD. Is it the day? Guys, I believe, just so you know, it is an honorable moment right now, those of you watching online. It is dumpster day.
Go in the other window too, don't be gross.
It is dumpster day. They're picking up the garbage right now. It's amazing. Amazing.
Oh, he even put the snow back
He's
inside.
plowing right now.
He's plowing with the dumpster, Mr. Waddy.
This is absurd. I don't know if you've heard this. This is an exclusive first time broadcast on the internet. They are plowing with the dumpster right now. I'm trying to describe the scene to you. Oh, it's savage for all garbage. Oh my goodness. The dumpster, imagine a full dumpster, but now it's empty.
It's empty and plowed.
And plowed.
With the dumpster.
He plowed with a dumpster. This is amazing.
Bye,
You are my hero.
Wow. So,
That'd be amazing.
I hope that dumpster emptied has left you inspired, that your brain is now ready to receive new, not garbage, but knowledge. Not to ever be emptied again, but to be continually filled with further information. How could I not? This is an amazing recording right now. Amazing. So 42 divided by 3 is
13, 14.
Yeah, what is it? Wait a minute. Does
17.
it's got to go in, right? Yeah. 2 times 7, 14, yeah, 14. 14. Ooh, there we go. And 14 times 2 is 28x. Right. 42 divided by 7 is 6, and 6 times positive 5 is 30. And 42 divided by 6 is 7, times 1 is 7. And now I could just go on and solve this normally. So I want to point out that in doing so, I cleared out fractions and then could solve normally. We're actually going to use exactly the same technique today for our new skill set. What? Crazy sauce is what you might say. If you're crazy for learning more math, that's right. Let's see. 23 is prime, I think, and also Michael Jordan's number. I've heard that as well. Yeah, Jacob. That's right. Jacob is as good as Michael Jordan at basketball. Jacob Jordan.
p.m.
So, let's do our first example of applying this to problems that maybe aren't necessarily like just plain old problems like that. Let's get into some rational equations here. So what if I've got x plus 1 over 3x minus 6 equals 5x over 6 plus 1 over x minus 2.
I don't like that.
Yeah, but our same skills will apply. All we have to do is build on top of them, like the remains of an ancient civilization. So the question is, first of all, we got to figure out what the LCD is.
3x minus 6.
3x minus 6, I don't think so. Because does 6 divide into 3x minus 6? I don't think so. In fact, the first thing I might do is factor these. They won't always be given to you factored. I think I could steal a 3 from that, if I'm not mistaken. X plus 1 over 3 times x minus 2 equals 5x over 6 plus 1 over x minus 2. So, looking at my numbers, I've got 3, 6, and I guess you could say 1. What do all of those go into? 6. All right, so 6 is part of my LCD. And between my other factors, my binomials, I've got an x minus 2 here, an x minus 2 there. How many x minus 2's do I need?
2. 1.
I actually just need one of them, because there's only at most one of them represented in either denominator. So, now, what did we do up here? We found the LCD of all the denominators, and we multiplied both sides by it. I did not multiply each fraction by the part of the LCD it was missing, right? I just straight up multiplied by the LCD. So there's a lot of different skills floating around in this. So step 1, find LCD of all denoms. Denom, right? And then step 2, mult both sides by LCD. And notice I'm not saying top and bottom, right? There's so many little distinctions going on here between our different techniques for dealing with our problems. And then 3 will just be solve. Because I anticipate that we will have killed all fractions. Killed all fractions. So here we go. Let's multiply both sides by my LCD. Here we are. So my LCD is 6 parentheses x minus 2. And over here, 6 parentheses x minus 2. Over here, I'm going to have to make sure I represent it twice. Here it's just going to be kind of represented once. So equals. Oh, actually, I guess it's not an equal sign, and there's an equation. My bad, my bad. These are all, each row is an equivalent equation is what they call it. Which actually, it's really funny if this is a less than sign, and this was a less than sign. These would be referred to equivalent inequalities, which in my mind, that sounds like an oxymoron, am I right? Equivalent inequalities, craziness. But anyways, so when I divide here, the x minus 2's swipe, swipe. 6 divided by 3 is 2. I'd be left with 2 times x plus 1. I'm not even going to multiply that out. I'm just going to really take my time so that way it's obvious what each step came from. All right. Here, when I multiply it by this, 6 parentheses x minus 2 divided by 6, what cancels out? And I'm left with x minus 2. So this is going to be 5x times my x minus 2. Okay, all right, we've got this. We can do this. And here, what cancels out? The x minus 2's, and I'm left with 6 times 1. Sounds like a plus 6 to me. What? And notice all fractions have been killed. Behold, our utopian society exists. So, that's an x minus 2. So let's see, let's distribute these. So this is 2x plus dose. This is 5x squared minus 10x plus 6. Let's see, there we are. Oh, behold, it's a quadratic equation. I'm guessing we should set this equal to 0 and solve using some of our previous techniques. Technique. and I'm going to flip it over here because I like this. 5x squared minus 12x plus 4 equals 0 is what I'm left with. Now, if I want to solve this, I can't GCF. Is it AC-able? I might try it. Let's see, 5 times 4 is 20. Factors of 20, 1 and 20. Ugh, that is not a 2. 2 and 10. Oh. And then 4 and 5 worked, or been factors anyway. So yeah, it appears as though it's AC-able. You also could have used completing the square. Not recommended with this value right here. Would actually have a lot of fractions to trudge through. And you also could have used quadratic formula if this was not factorable. Not all problems are factorable. All problems can be solved with quadratic formula if they're quadratics, as well as the completing the square method. So let's see, let's split the b term into two like terms whose coefficients of the factors we just found. 5x squared. I'll throw a, what are you guys in the mood for? 10x and then a 2x? I'm thinking that as well. And what are their signs going to be? Negative, negative. They have to multiply to be positive, so their signs are the same, and add to be negative. So negative, negative. And negative 10 plus negative 2 is negative 12, so that works out. And now, of course, I do the factor by grouping yoink, yoink, and yoink, yoink. Between these two, I could steal a 5x. You guys are all masters of the AC method. You know what's up. What's up, AC? We haven't seen you in a while. How's it been going, man? AC, represent. And let's see. Hey, our parentheses match, which they gotta. So I'm going to have 5x minus 2 in parentheses and an x minus 2 in parentheses equals 0. Now, if those are my factors, how do I find my solutions?
Set both of them equal to 0 and solve it.
And you might even be able to know the solution to this one right away, because we remembered that back in our day we knew that factors and roots, there was an opposite sort of relationship going on there. This one might not be as obvious, the one on the left. Do 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 ba da ba 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 da ba. So I get one solution here, and 5x equals 2. How do I solve that? 5 by 5. I like it. I like it. So x equals 2/5. Now, question. Rewind back to when we were graphing rational functions, and we talked about domain. What value of x would not work in this equation?
2.
Yeah, 2. 2 does not work in this problem. Why?
You can't divide by 0.
Because I can't divide by 0, and 2 minus 2 is 0, or depending on if I view the factored version of that, 3 times 2 is 6, and 6 minus 6 is 0. So you could have actually thought of this as having a restricted domain where the domain was the set of all x such that x could not equal 2. All right, so it turns out, back to the future, this guy is extraneous. Oh dear. However, this one, 2/5, we're cool with 2/5. Even though we just tried to kill fractions earlier, they came back. That's fine. It's fine. We love it. So 2/5 right there is a legitimate solution. All right? So I just want to point that out. With these problems, you might have to consider a restricted domain because we've got so many denominators floating around. It means there might be some values of x that don't work. Don't work. All right. So this was our first example where I had big crazy equation. I killed the fractions using the LCD. All right, that's the general idea. Let's look at one last example. And this in this problem, you know what? I'm going to write it this way, just because I can. I'll have 2 over x plus 2 equals x minus 3 over, ready, x squared minus 3. Aha! Now, one subtly difference between this problem and the previous one was the previous one had like multiple fractions on one side. This one only has one fraction per side. All right. I still can use exactly the same technique I just did, although at times it might be beneficial for you to do what's called cross multiplication, which can be used anytime you have a fraction equal to a fraction. All right. So if you have a fraction equal to a fraction, you can cross multiply. You could cross multiply.
I don't know what we're gonna do.
Oh, I don't know. This might be worth looking at both ways or something. We'll see. But I just want to point that out. I've got a fraction equal to a fraction. Do you guys remember what cross multiplication was?
Multiply by.
That said, if I have A over B equals C over D, then that led to the following: AD equals BC, where you literally would multiply B and C and A and D and set them equal to each other. Okay? Hence cross multiplication. So I can use that technique here. That won't always be the best technique. Maybe if I realized there was some other crazy, X's up here and I didn't want to necessarily get some of those, I might want to try to avoid some high degree polynomial if possible. That's not always going to be avoidable, but whatever.
X is 5.
X is 5? Interesting. I don't know. I actually don't know. I don't have the answer written down here. I just got a problem, and I know it needs solving. Now, actually, let me ask real quick, what about the restricted domain before we try solving this? What values of x won't work?
-2.
X is not equal to -2.
Right.
When would this equal 0?
0. Or 1.
Well, think about x squared minus 3 cannot equal 0. X squared cannot equal 3. X cannot equal plus or minus the square root of 3. All right. So I just want to point that out that we've got some restricted domain values. So if I get one of those solutions, they'll be like, you're extraneous. Can't fool me. That's what I would tell it if I had to. So let's try cross multiplying. All right. So 2 times x squared minus 3 equals, and I'm not even going to multiply it out yet, x plus 2 times x minus 3. So this is cross multiplication.
Is that like the whole thing?
No, well, now I get to solve it.
Well, was that like the whole cross multiplying?
Yeah, that was all I had to do for cross multiplication, yeah. And then here I could FOIL or double distribute or whatever, right? Here we go. 2x squared minus 6 equals x squared minus x minus 6 when you FOIL it out and combine like terms, because you'd end up with a 2x and a negative 3x. Those combine to be negative x. So I'd end up with a quadratic. How do I solve this?
It's x plus 3. No, x plus 2. X minus 3. Right?
Oh, you're factoring this.
Can't you do that first?
I don't. That's a good thought, but I don't want to factor it until it's set equal to 0, because factoring is only useful when it's set equal to 0, because the zero product property would then tell me that I could set each factor to 0. So I understand your temptation, but we actually want to set it equal to 0 first. But good thinking, good thinking. It's not a bad thing. Add 6 to both sides. All right. So let's set this equal to 0. So 2x squared minus x squared is a 1x squared. 0x plus x is x. Negative 6 plus 6 is 0. And that equals 0. Oh, I like this. How would you guys, this is factorable. How would I factor that?
Completing the square.
You could. You'd have some fractions to work through a little bit, but there's another way. There's a way I could actually factor it, though.
Oh, GCF.
Yeah, yoink, yoink. Yoink! Steal an x out of there. Because there's no c term, with no x, so everybody has an x. X parentheses x plus 1 equals 0. And now ZPP, zero product property. Either x equals 0 or x plus 1 equals 0. So that's going to mean Those are my solutions, right? Right, where this one, of course, came from subtracting 1 from both sides. Now, I thought x couldn't equal 0. Is that what I said earlier?
Yeah.
I said the denominator couldn't equal 0. Would either of these denominators equal 0 if x was 0? No, 0 plus 2 is 2. 0 minus 3 is negative 3. That's fine. And what about the other one? Negative 1? Negative 1's cool too. So it appears as though this problem's got dos solutions. And I could go from there. All right? It's not that bad. So I just want to point out cross multiplication could work. You don't have to do it though. I also could have just found the LCD between both of these, multiplied both sides by it. It actually would have led me to a similar result. But I just wanted to point that out. If you have a fraction equal to fraction, it could work out like that. Real easy. So have a great day, friends. Bye-bye.